test. So if you have any questions in chat, I have several that we're going to go over. If you tried to get into the live stream on Wednesday, I apologize, it didn't post as planned. So I'm going to go over some of those problems, and I have one additional request for something that's due today, which is this problem number 5, which is about logs. So we're going to start just by kind of reviewing the week, right, and some of the problems that you might have seen earlier. So again, if you see anything additional on either the one-to-one structure understanding of the homework or the log stuff, just post that in chat and I'll go over that as well. Okay? So just quickly go over some of this one-to-one stuff. Here's the kind of concept that we talked about. So let's just kind of review real quick. So what we basically said was, we have a true expression like this, which is 2 to the third is equal to 8. Okay? And then I had a statement like this which said 2 to the third is equal to 2 to the something, right? It's pretty obvious, I think, looking at this, that the only thing that x could be is 3, right? So when the bases are both the same, 2 on the left, 2 on the right, thank you for that. I will see if I can fix it. Hold on. My voice is muffled. Let's see. It's the thing that it's supposed to be. Oh, actually, I might know why. Let's fix that real quick. Okay? So, just wire back here.
All right. Does that help? Does it sound any better? My one of my wires was not plugged in all the way, so let me know if that helped. Okay, so if I don't get any issues, I'm going to keep going. Okay, so again, 2 to the third. Okay, good. It was a little wire that was not all the way plugged in. Okay, so again, the idea here is with 1-to-1, if I have the same base on the left and on the right, and I have 1 on the left and 1 on the right, that's why it's called 1-to-1, that I can just set the exponents equal to and say 3 has to be equal to x, which is, I think, pretty obvious in this case. All right, a problem like number 12, this is from the check for understanding, I believe. I can take the number 8 and the number 32, and I can make them both into base 2, right? So I can rewrite 8 as 2 to the third power, right? I can rewrite 32 as 2 to the fifth power, right? So we're trying to get one base on the left, one base on the right that are the same thing, in this case, base 2, okay? So I did that. 8 became 2 to the third, and then what we said to do is to, if there's an existing exponent like x minus 1, put that in parentheses right next to kind of what was already there, okay? Equal sign, and then the same thing on the other side. I'm going to say the existing exponent was 3x minus 2, okay? So in this case, I have now the same base on the left and on the right. So just like here we set the 3 and the x equal to each other, I can take this expression, and I can set them equal to each other. So here's what it's going to look like. 3 times x minus 1 is equal to 5 times 3x minus 2, okay? And then this is just a linear algebra solving problem, right? I can distribute the 3x minus 3. I can distribute the 5 and get 15x minus 10. And then I'm just going to solve. If I subtract the 3x over, I get 12. Okay? If I add the 10 back, I get 7. And then if I divide both sides by 12, we get that x is equal to 7 over 12. Okay? So that would be my answer for that one. Okay? And any other problem where it's exponential equals exponential, this is going to be a strategy that you can use. It doesn't always work, but it's something that you can definitely try. Sometimes it's not possible to get the bases to be the same, right? But if we can, that's your easiest bet. Okay, so that's problem number 12. Okay, someone also asked about 14. This is a kind of a variation on that. Let me get rid of my text in my GIF. Okay, so 14 is very similar. If you can kind of see that there's a lot of base 10s. Okay, the difference here is that the first thing we need to do now is on the left-hand side, I have 2 base 10s, right? So again, let me remind you about a little strategy that we have with exponents, a property, right? If I have something like x squared times x to the third, we said if the bases are the same, in this case they're both x, that I can put them together, keep the base the same, and I can say 2 plus 3 makes 5, right? And I can say x to the fifth. So I can do the same thing here. If I have base 10 and base 10, I can say, well, let me put those together, and I can make a base 10 combined by adding together negative 3x plus x, which is negative 2x, okay? Notice I did not multiply the 10s together, right? Just like how I didn't change the base of x over here, I left it alone. Leave the 10 as it is, okay? On the other side, this is kind of a tricky one. Okay, let me kind of show you what's going on here. If I have a something like, let's say, x to the negative third, right? The way we said to fix that was to move it in a fraction. So if I have x to the negative third on the top, I can move that to the bottom, and that becomes x to the positive third on the bottom, okay? So I can actually reverse this. If I have x to the positive third on the bottom, I can move it back to the top and make it x to the negative third, right? I'll just put a 1 there, right? I could do that over here, right? The 10 is really 10 to the first power, right? And 10 to the first power, if I move this up in its fraction, will become 10 to the negative 1, okay? Like that, okay? So now I can say 10 to the negative 1 is the same as 1 over 10 to the positive 1, right? And now I have 110 on the left, 110 on the right, right? This is a 1-to-1 function, so that means that I can set the exponents equal and say that negative 2x is equal to negative 1. If I divide both sides by negative 2, I'm just going to say positive 1/2 because the negatives will cancel each other out, right? So this is a pretty much the same thing as this one. The differences are in problem number 12, we did not have to combine anything on the left. And in problem number 12, we actually had to change the bases into something else, right? 8 became 2, 32 became 2. The 10s here were kind of already all good, but we did have to combine on the left, okay? So if there's any questions about these two, this is kind of a good examples of the 1-to-1 property. Okay, this is what was due on Wednesday, but if you still hand that in, you still get credit for it. So I want to make sure we have a chance to see a couple of these, okay? All right, so again, if there's any questions, just post those in chat and I can pop back to them. Okay, so let's talk about a couple log problems. I got problem number 6 from the Check for Understanding, which somebody had asked about, and then this is problem number 5 from the homework that's due today, which I can go over as well, okay? So let's start off with this one. I think this is a little simpler, okay? So let's go back to the beginning before we get to this problem. What we basically said logs were a question, right? If I did something like this and said log base 2 of, we'll do 16 just for a little variety, okay? We said that this is really asking the question, 2 to what power gives me 16? And so I can say the answer to this is 4, right? So if I have an equation that includes logs, I can actually rewrite this as an exponential and say, if this is the base, the 2, okay, the other side is the exponent, 4, okay, the answer to that is what we're evaluating with the log, which is the 16, right? So I can convert a log like this into its exponential form by reorganizing the numbers that are in the log, right? So if I have a problem, an equation like this, and I need to solve, I can do that. But the one catch is you have to get log by itself before you do this conversion step over here. So this negative 2 that's sitting on the outside, I'm going to divide by it, okay? Because this is really negative 2 times the log, okay? If I divide both sides by negative 2, the left-hand side one will cancel, and I get log base 8 of, I'm going to write x plus 1 because my a's look like 9s, especially when I write with a writing slate, okay? And then if I divide on the right, it just becomes positive 4, okay? So now this and this thing are pretty much the same, right? I have a log, I have a base, I have an expression. That equals the answer on the other side, okay? So now what if I'm going to do my conversion? I'm going to turn this into its exponential. Here's my base, that's 8. Okay, I have an exponent on the other side, which is 4, okay? And that's going to be equal to the expression that's inside of the log, which is, oh, I don't need the parentheses, x plus 1, okay? So now I got a little calculator work to do. Let me grab my calculator, okay? So 8 to the 4th power, so I'm going to 8x to the y 4 is 4,096, okay? So I'm going to say that is 4096, okay? And then if I just subtract that 1 over, I get 4095, okay? That's x, okay? So that would be the value that you want to put in here for A. And that actually does work. If you look at this original problem, 4095 plus 1 is 4096. If I were to say log base 8 of 4096, what I'm saying is 8 to what power is 4096? Well, I know that. We just did it, right? This is really 4. And then this says negative 2 times 4, and that is negative 8. So that works out, right? So 4095 is the value that we want for A in the original expression, okay? So if there's, again, any questions about solving this type of log, go for it, because this problem right here is a challenging one, right? So you definitely want to have a good understanding of simpler problems like number 6, okay, before we move on to this thing. So if you have any questions about solving logs, post those in the chat, okay? Here's problem number 5. Okay, this is one that's on the homework that's going to be due today, so good one to see if you're having some issues with some of the more challenging ones on there. Okay, so here's how we're going to treat this one. I'm going to kind of grab my highlighter real quick. Okay, and I'm going to highlight the log portion of this ugly looking expression with the 2x squared in it. Okay, there we go. Okay, if you notice, I have a 9 times this minus 7. If you think about this thing like a regular old equation, if I just said 9x minus 7 equals 11, right? And kind of pretend like the log is just a regular old. Oop, I did not mean to change that color. Okay, there we go. I wanted to get my highlighter out again. And if I were to say this x is the same as this log, and just kind of think about things that are easier to solve, it's really easy to solve something like this. We would take this expression and say plus 7 on both sides, okay? And we'd get that 9x is equal to 18, okay? And then I would divide by 9 on both sides, okay? And then x would be by itself, and it would be 2, okay? I'm literally going to do the exact same thing here. Okay, I'm going to add the 7 over. I'm going to divide away this 9, because instead of trying to get x by itself, I'm trying to get log by itself. But the same process applies, right? So I'm going to say that this is 9 log of 2x squared plus 35x. Okay. And then if I add this 7 over, that's going to be 18 on the other side. Okay. And then I'm going to divide away this 9, okay, and it'll be log, okay, of 2x squared plus 35x, okay, is equal to, and if I do 18 divided by that 9, I'll get 2, right? So kind of just getting the variable alone. So I'm going to get rid of this whole right-hand thing, because we're going to need the space, okay? All right, so now I'm here. This is the conversion step. Log is by itself. On this problem, we had a base of 8, okay, and we had an exponent on the other side of 4, okay? The difference with this problem number 5 is there is no base written here. I know the exponent on the other side's 2, right? Whenever there's not a base written, we assume it's base 10, right? Our whole number system is a base 10 number system, so that we don't usually write it. If we just write log, right, we assume that it's really log base 10, okay? So if I kind of go to the other side now and say this is 10 squared, right, is equal to whatever's inside of the log, which is 2x squared plus 35x. Okay. Whenever I see a squared in my problem, my first thought is try to set it equal to 0, so I can try to factor or try to use the quadratic formula. Those usually involve it being equal to 0. Okay. So I'm going to subtract this 100, right? This is 10 squared to the other side. It's going to be 2x squared plus 35x, okay, minus 100. Okay. And that equals 0. Okay, so now my job is to try to like factor this in some way. All right, so we have to think about what numbers multiply to negative 200 that add to 35. So negative 200 is my AC, okay, and my B is 35. And if you don't want to do this, you can also just use the quadratic formula if you want. So let me pull up my factors of 200. Okay, so factors of 200. Okay. So 200 with a 35 involved, okay, it's probably going to be 201, 102, 50 and 4, 40 and 5 looks right? So 40 times 5 makes 200, right? So I'm going to say that if I make this positive 40 and negative 5, okay, that would add up to positive 35, right? And it would multiply to negative 200. So I'm going to take this middle expression, this 35x, and I'm going to rewrite it. I'm going to say 2x squared, okay, and the minus 100, I'm not going to change, okay? But I am going to take this 40 and negative 5, and instead of writing 35x, I'm going to say plus 40x minus 5x. Okay, so that's how I split my expression, and the reason I'm doing that is because now I have the grouping method. I can take this group, okay, and I can take the 2x that is shared between those, okay, and that looks like x plus 20, okay, and then this one's got a negative 5 in common, so I'm going to say negative 5, also x plus 20 is left over, okay, and then I'm going to regroup. I have an x plus 20 in common, that is one of the factors, okay, and then I have 2x and a minus 5 on the outside, so I'm going to make that the other factor, okay. And these are my answers, right? I can set each of these equal to 0, right? The whole thing's equal to 0. So this one gives me that 2x minus 5 equals 0. And if you solve this, you get that x is equal to 5 over 2, okay? The second one is x plus 20 equals 0. So that's negative 20. Okay? All right, so that's our answer. Okay, there's kind of a little catch, though. We have to do a check, and I don't know if this was in this particular video or if it's going to be in the next one, but I'll talk about it real quick right now so you'll see it. There are extraneous solutions when we talk about logs, okay? And I'm not sure if this one has one. We're going to check it right now, but here's the idea, okay? If I were to do this, let me kind of give myself a fresh screen. If I were to do this and say log base 2 of negative 4, okay? And say that is equal to what? Okay, if I ask that question. This is something that actually does not have an answer. Okay, I can't solve this, and here's why. Okay, it is impossible for me to take 2 and raise it to any power and have my answer come out to be negative. And the reason for that is 2 is positive, right? If I say 2 times 2 times 2 as many times as I want, my answer is always going to be positive, right? So it's impossible for me to do 2 to any exponent and have my answer come out to be negative, okay? So kind of as a summary, this number, okay, in any log problem, okay, it has to be greater than 0. Cannot even be equal to 0, okay? Has to be greater than 0, okay? Because you also can't do 2 to some power and make it equal 0, okay? So this number is negative. That means that that number is not good. So if I come back to this problem, if I plug in 5 halves, I know I'm okay, right? Because if I square a positive and multiply by 2 and add it to another positive, I'm fine. No issues there, okay? This negative 20, though, might cause an issue. I don't think it's going to in this case, but we're going to double check, okay? So I'm going to plug in, oop, don't need that. Here we go, okay? So we're going to do 2 times negative 20, okay? Negative 20 times 2, okay? Oh, negative 20 squared, okay, times 2, okay, let's try that again. Negative 20 times negative 20 is 400 times 2, okay, equals 800, and then I'm going to subtract from that 35 times 20. 35 times negative 20, so 20 negative. That's not right either. This is not my usual calculator. So let's try this again. So 35 times 20 with a negative sign is negative 700. So we're okay. 800 minus 700 is positive. No issues there, right? So these are actually both good values, right? So 5 halves is a good answer, okay? And negative 20 is also a good answer, okay? So that's the kind of like pretty difficult problem. There's a lot involved here with the base missing and having to get rid of all this other stuff, then having to do factoring. So if you have a good understanding of something like this, you're in a really good place because this one's pretty challenging, right? I thought, okay? So is there anything else we want to go over? This was a little bit of one-to-one, okay? A couple of variations of one-to-one. We had a slightly simpler log problem with this one, okay? And then we had a much more complicated log problem here, okay? Could you go over number 4 on the worksheet due today? Yes, I can. Let's see. Number 4. Okay. Oh, so this one's got a fraction. So this is another good one to look at. Okay, so let me snip it. Here's number 4. So this one's not going to take us near as long as the other one because there's no factoring involved, but it's a good problem to see with the fraction. So here's the idea with this one. Let me go back to this one because I think it's got our good example. Okay, so this one we saw this idea that if the log is by itself like this, that I can then do a conversion step and turn it into an exponent form. All right, and the way we did that was we said if the base is 8, on the other side the exponent's 4. What was after the base becomes the answer to that problem, right? The x plus 1. This problem, right, number 4, is already ready to be turned into its exponential form, right? There's nothing outside of the log that's being multiplied or added or subtracted. So right away, what I can do to solve this one is say that 64 is the base, Okay. The exponent is what is on the other side, which is 2/3. Okay. And that's going to be equal to what's inside of the log, which is just x. So this one's actually already solved for us. The only thing we have to do is 64 to the 2/3. Okay. You can grab a calculator to do this. So we'll do it real quick at the calculator so you can see that, but I'm also going to remind you about what that means. Okay, so 64 to the, and then I'll use my parentheses, 2 divided by 3. Okay, and then hit enter, and that's going to be 16, right? So it looks like 64 to the 2/3 is equal to 16. Okay, and that's your answer. Okay, so to remind you about why it's 16, here's what we said. We said that the bottom of the fraction is really a radical. It's a cube root, right? So I could rewrite this one as the cube root of 64, okay, squared, right? Like if I broke this up, let's kind of show the middle step. 64 to the 1/3 squared, okay? That's the 2/3, right? And then I can say 64 to the 1/3 really means the cube root of 64. Well, the cube root of 64 is 4, okay? And then 4 squared is 16, right? So if you don't have your calculator handy and you just want to evaluate this one, it does simplify real nice, okay? So this one is just convert and then deal with that fraction exponent, okay? So is there anything else either on this worksheet, right? This is what's due today if you want to see. So we did some problems on here. Okay, so if you want to ask anything else about this, okay, that is due today. If you did not get a chance to do the other worksheet that's due, okay, I know that the live stream didn't work as well on Wednesday. So if there's anything on here that you want to go over, just a little hint if you didn't notice, the answers are posted at the bottom. I'm going to want to see work too, but if you have any questions about this that you want to go over, we can do that too, okay? So if there aren't any other questions, okay, I'm going to hit the mute button. I will be here for a little bit to see if anyone else pops in for a question. Okay, and otherwise, have a good weekend, and I will see you guys next Wednesday. We'll do this again, and I'll have some review for you. I'm not going to do anything new next week. We're just going to have a chance to kind of process all this and work through it. Okay, so I'll be here for a little bit if you have any extra questions.